Hey guys, so today we're gonna kind of pick up where we left off with 2-3 synthetic division and curve sketching. So today we talked about the factor theorem. Factor theorem honestly should just be second nature to us because basically what it says is this. If you have a factor of some polynomial, basically what it means is if your factor is x minus a, then f of a has to be 0, which makes sense. If you have a factor, say you have, in this case, we have x squared plus 5x plus 6, well, their factors are x plus 3 and x minus x plus 2, which means their zeros are negative 3 and negative 2. If you plug negative 3 and negative 2 in, you should get 0, which makes sense because the whole point of a factor, the whole point of a 0, is that it's where the x-axis hits the graph. It's where the graph is equal to 0 in respect to y. So factor theorem kind of makes sense just intuitively, so let's go ahead and use it. First question says this. Okay, I have this big, huge polynomial here, and it basically says, okay, show that x minus 2 and x plus 3 are factors. Well, honestly, using the factor theorem, I can show that like that. I can literally show it really quickly because if I plug something that is supposedly a factor in, I should get 0 out. So if I plug in f of 2, and I just did this in my calculator, I'm going to get 0. And if I plug in f of negative 3, I also get 0. And so what I can see here is that these have to be factors because if I plug them in and I get zeros, that means that they go into the graph perfectly. And if I plug them in, it would cause the whole graph to go to 0. One other way that I showed the class how to do this is to use synthetic division. So if I synthetically divide this graph, this equation by one of the factors, so I think I picked 2, I should get a remainder of 0, which I did. Technically, we were supposed to check it for the other one, but we were running a little bit low on time, so we didn't. Okay, next thing we talked about. All right, so the next thing we talked about, we were given this graph. So we were given this graph, and we want to know, hey, what's the equation of the graph that goes through the point negative 3 comma negative 9 and looks like this? So basically, there were kind of 2 or 3 steps that we started with. First step is we identified the zeros. The zeros happen at negative 4, 0, and 3. Specifically, if I want to write zeros as factors, and remember when we talked about how zeros and factors are kind of one and the same thing? This is kind of where it's coming back to us. So if I want to write x equals negative 4 as a 0 as a factor, I can write it as x plus 4. If I want to write x equals 0 as a factor, I can write it as x. Don't pay attention to the square quite yet. And if I want to write x equals 3 as a factor, it's x minus 3. Now the question is, okay, it looks like it crosses here, bounces here, and crosses here. And I know that when I have multiplicity that is odd, I should cross. And when I have multiplicity that's even, I should bounce. And that's from the last video. So I know I'm going to cross here, I'm going to bounce here, and I'm going to cross here. So I'm going to raise each one to an odd or even power depending on the crossing and bouncing. If it's crossing, I'm going to raise it to an odd. Specifically, I think the easiest one to raise it to is probably 1. I'm going to raise it to the first power. X squared, the easiest thing I could raise it to is probably, why did I say x squared? X, I'm going to raise it to the 2 because that's even, so it bounces. And x minus 3 is odd. So really all I want to check now is make sure my end behavior is correct. So my end behavior is determined by taking all of the exponents, adding them together to see what the highest exponent would be if I multiplied them all together. 2 plus 1 plus 1 is 4. So my highest degree is 4. And look, the greatest amount of zeros I could possibly have is 1, 2, 3, 4. So 4 looks like it's a good idea. Also, the end behavior of something raised to the 4th is either all up or all down. Specifically, I know that it's all up because there's no, in this case, it's all up because we want it to be, I guess oh my goodness, I cannot talk right now. I want the coefficient to be positive because this is facing up. So this only works if I have an even highest degree and a positive coefficient associated with it. So I'm going to put a positive 1 in front of everything and multiply it all together. So 1 times x squared times x plus 4 times x minus 3 is equal to f of x. Now that's pretty good. That's a good approximation, but it's not perfect. What happens if we plug a point in? So basically, I want to know, hey, what's the equation that has all of these zeros, and it goes through the point negative 3 comma negative 9. To find that, really what we're asking for is they're saying, hey, I don't know what the a value is. I know the a value is going to be positive because it faces up, but I don't know exactly what A will be. So I assumed it to be 1 here, but we don't know that for sure. So what we want to do is try to solve for A. The best way to solve for A, if I think about it, is if I have a point, 3 comma negative 9, I'm just going to plug 3 comma negative 9 into the equation. So I'm going to plug in negative 3 for x and negative 9 for f of x. When I solve this, I'm going to get A is equal to a sixth. So the actual equation is going to be 1/6 x squared times x plus 4 times x minus 3. And that actually there is the actual equation of the graph that goes to the point negative 3 comma negative 9 and has the following attributes, opening all the way up on both sides with zeros that are listed. All right, so that's basically what we did in class. After that, we just practice on whiteboards outside, and your homework for tonight is just to work on WebAssign 2-3, which is due tomorrow at 3 p.m. If you have any questions, feel free to message me, and I hope that you have, I don't even know what today is. I think it is a Wednesday, so have an awesome Wednesday. See ya.